everyone, in this video we're going to go through measures of center and measures of spread. So measures of center is your mode, mean and median. So just basically tells us the average. So when we say average, it doesn't always mean the mean. It could be the mode, it could be the median. So we call them measures of center. Measures of spread, if I just scroll down, is your range, your interquartile range and standard deviation. So with these different measures of center and measures of spread, we do use them depending on what sort of data we have. So for the mode, we can use it for either numerical or categorical data. Definitely for categorical. So if we were doing the eye color or your favorite football team, there's no way you could calculate the mean or the median because they only apply to numerical data. So the mode you can use for both numerical and categorical. Now, for numerical, it's often used for discrete because thinking of something like the number of pets in your family, you're going to have discrete values, and it's going to probably be very common, most of your answers. So you'd probably get anywhere from 0 maybe up to 6 pets in a family. When you're dealing with continuous, we tend to say the modal category, or it could be the modal interval. So when we look at histograms, I'll probably explain that a little bit more. We can have bimodal data, bimodal data sets. So that means you've got 2 modes. As soon as you get more than that, we just say there's no mode. So you don't have to always have a mode. For the mean, we use that for numerical data. So basically you just add all your values, so sum all your values and divide it by how many you have. So your calculator can do your mode, your mean and your median, but there's the formula there for your mean, which you've probably been calculating since year 7. So this is nothing new. And then the median, you do have to make sure that your data is in order. So we do it from, you can do it from smallest to largest or largest to smallest, but we do need to make sure that we take the middle value. All right, so if we've got, if we're finding this median, sorry, I'm just trying to read as I talk, just having a look at step 3, if the number of values you have is odd, then we find the n plus 1 divided by 2 position. All right, so if you've got 16 values, sorry, that's not an odd number. If you've got 17 values, you just do 17 plus 1 divided by 2, and that'll help you find your median. If you've got an even number of values, then we do n plus 1 divided by 2 again, but we do the average of the 2 values, all right, because it'll be either side of that. So it's a little bit easier when it's odd because you've got a distinct middle value, but when it's even, you're basically separating them into 2 even groups, and then you've got to find the middle value. Anyway, I'll talk more about that when we have a look at the median. In terms of your range, easiest thing ever, it's just your largest value minus your smallest value. So very easy to calculate the range. The interquartile range a little bit harder because we do have to calculate Q3, which is your upper quartile, and Q1, your lower quartile. And it is the middle 50%. And often we look at the interquartile range when we look at box plots. So we'll look at that in more detail then. And then your standard deviation is another measure of spread, and we just say what it is around the mean. And we tend to just use that for symmetrical data. I was trying to find the word there. Just having a look at this color diagram before we move on to some questions. So if we've got nominal data, so it's categorical but it's nominal, all right, the measure of center we use is the mode. There is no way to look for the measure of spread, that's why there's nothing there. And the chart that we would use is either a dot plot or a bar chart. If we've got ordinal data, we can find the mode or the median. If we've got the measure of, and the median because we can put it in order, measures of spread, we can use the range or the interquartile range. And the display, we can use a dot plot or a bar chart. So you can see for categorical, mostly using dot plots or bar charts. All right, for numerical data, we can use the mean, median or mode median or mean. we can find the range, interquartile range, and standard deviation, and then we can display it in a dot plot, a histogram, a box plot, or a stem plot. All right, so different ways we can do that. Just over the page, we do have just the different charts that we can do and like a little bit more information on them, but we're going to have a look at them in different videos. So just focusing now on measures of center and measures of spread. All right, so let's have a look at some questions that relate to this. So measures of center and spread. So this relates to 1F in your textbook. So we have kind of jumped ahead a little bit. Just to recap, mean, median, and mode, and range and interquartile range. All right, so we're not covering every single question from your textbook, but hopefully enough to give you an idea of, the topic that we're covering. All right, the following stem plot shows the distribution of the time it took in minutes for each of a group of 25 people to solve a complex task. When you're looking at stem and leaf plots, just make sure you take note of the key. So there will always be a key with a stem and leaf plot. So 4/0 represents 4.0. So it's not 40, which sometimes it would be, it's 4.0. So your time here would be 4.2. I might just list a few to show you. So the first one would be 4.2, then we have 4.6, 5.1 when we go down to the next row, 5.3, and so on. All right, so we need to find the median and then we're going to find the range. Now, putting all these values into your calculator can be quite time consuming, so it's better just to do it from your graph, although you can enter all this into your calculator, but it would take you a lot longer than just doing it from the graph. All right, so we've got 25 people. So remember the formula for finding the median, although it's just your middle value, so you don't really need to use a formula. So we've got an odd number, so we're just going to do n plus 1 divided by 2. So we've got 25 people. Actually, let me just write this here. So our median, 25 plus 1 divided by 2. So our 13th position is our median. So I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And there it is. So it's going to be 7.3. So make sure you read it correctly with that key. It's not 73, it's 7.3. Now, just to double check, you can make sure that there's a same number either side. So we should have 12 either side. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. And then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so the 13 spot is our median. Now the range, remember the range is your highest value. So for this one, it's 10.6 minus your lowest value, which is 4.2. You can put that into your calculator, but I'm just going to give you the answer now, is 6.4. All right, so that's the range. So the range basically just tells you how varied the data set is. So if I was, this is just a little side note, if I was to do the age of students in year 12, so age of year 12 students, they'd probably go anywhere from maybe 16 to 18 years old. If I was to do the age of year 7 to year 12 students, we might have some who are still 11 up to 18. So your range for this one would be, oops, it looks like I'm doing a takeaway there, which isn't. I might just get rid of that. All right, so your range is 2 for that one, and your range for the other one is 7. So the greater your range, the more varied the data set is. That's what the range tells us. All right, moving along, determining the median and the quartiles. So what it means by quartiles, if you think of quarter, you're just splitting the data set into 4. So when we look at box plots, you'll look at this in a little bit more detail. But we've got a set of data, we split it in half to find the median, and then we split those halves into half again, so we get a quarter. All right, make sense once I show you. So we've got 14 families. So to find the median, remember we do 14 plus 1 divided by 2. So that's going to be 15 divided by 2, which is 7.5. So when I've got a 0.5, it's just because I'm dealing with an even number. So I'm going to find the 7th number and the 8th. So your median is between the 7th and the 8th dot. All right, so let's count them. We've got 1, 2, 3, 4, 5, 6, 7. All right, so I'll cut there. And there's our 8. So 1, 2, 3, 4, 5, 6, 7. So we can see cutting it there, we've got 7 on either side. Now it just happens to be in the same column, which is 2. So your median's going to be 2. When you think of this dot plot, only because I'm not going to do a video on dot plots, what this means is we've got 0 occurs 3 times. All right, we've got 1 occurring twice. So each dot represents a child. We've got the number 2 occurring 5 times. Whoops, I was about to write the number 4. We've got 3 occurring twice, 4 occurring once, and then 7. So I can put my data in order like that as well, but you can see easier just to do from your dot plot. All right, so counting along, 1, 2, 3, 4, 5, 6, 7. All right, just like we did before, there's our cut. So halfway between 2 and 2 is still 2. Now, when I do my lower quartile, which is Q1, I'm doing halfway on my lower half. So here's my lower half here. That's why it's also called the lower quartile. This time I've got 7. All right, so my middle value is going to be the 4th value. You can do it the same way as before. So your Q1 is going to be 7 plus 1 divided by 2, which is your 4th value along. So 1, 2, 3, 4. So it's going to be this number here, which is 1. Let's just change this. So my 4th value, so Q1 is equal to 1. And you can see that on here, a bit easier. All right, there it is in the middle of my lower half. Now Q3 is halfway in your upper quartile. So here's our upper half. So we've got 3 here, you can clearly see is in the middle, or we can take the 4th value of the upper half here. So we've got 1, 2, 3, 4. So there it is there. All right, so Q1 was our lower quartile, Q3 equals 3 is our upper quartile. Q1 equals 1 is our lower quartile, sorry. All right, so our interquartile range is just our upper quartile minus our lower quartile. Just curious whether those notes were on here as well. All right, so here's your formula for the interquartile range, Q3 minus Q1. So for this one, we've got 3 minus 1 is equal to 2. So with your quartiles, here's our Q1. This was our Q3. So it just means that 50% of the values fall between Q1 and Q3. All right, that's what your interquartile range is. When we do a box plot, it will make more sense. All right, calculate the range, which is pretty straightforward. It's just your lowest value minus your, your highest value minus your lowest value. Sorry guys, it is Friday evening and I'm extremely tired. All right, 7 minus 0. So your range is 7. And then by writing the data values in a line, which I've already done, check that the quartiles and the median have divided the data set into 4 equal groups. Okay, well there we go. So we've got our 4 equal groups. So we've got 1, 2, 3, 4. They're our equal groups there. All right, let's move along. Calculate the mean and locate the median and modal values of the following scores. So if you're doing the median, they do have to be in order, but I just put this question on here to show you how to do it on your calculator. So this one probably would be quicker just to not use the calculator, but we're going to use the calculator anyway. All right, so let's just clear what we've got in there. All right, and we'll quickly enter the values in. just make sure it's, I was hoping it would say 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. Let's make sure we've got them all entered correctly. All right, so we go calc, and because we're only dealing with one variable, we're just going to choose one variable, and it's all in list 1. All right, and then we get this data here. So this first value, x bar, is your mean. So I'm just going to point out the important things to you. So there's our mean, so we can write that down. All right, so remember your mean is also your x bar. And I can't remember what it was. What was it, 3? All right. Now you don't need to worry about these next few things. Sx is the next important thing that you will know later on. We're not going to write it down now, but that's your standard deviation. N is how many values you have, which we know is 11. All right, then you've got your 5-number summary, which we'll be doing in a later video, but you've done 5-number summaries before. And there's our median. MED is our median, which is 3. And then we can see our mode. So we've got mode here, which is 2. So that means 2 occurs the most. And I'm just going to explain what those other 2 things mean. So mode F means how many times it occurs. So the number 2 occurred 3 times. And mode N is how many modes there are. So there's only 1. So if it was bimodal, that mode N would say 2. All right, let's have a look at the next data set. So we'll clear that. All right, quickly entering your values. So make sure you're doing this as well, just not watching me. So you can pause at any time, fast forward as well if you like. All right, so we're going to calc. One variable, it's already in list 1. All right, so there you can see your mean is 5. And scrolling down, our median is also 5. And then we've got a mode, which is also 5. All right, so not that this question asks you, but usually when your mean and median and also your mode are all equal, the data set is usually quite symmetrical. So if we were to graph that, which I can quickly do, not that we need to for this question, let's just have a look at it. So we'll put in a box plot. It's probably the easiest one to do. And then we'll quickly graph it. Oh, it looks negatively skewed, but I think that's because of the 12. So if we get rid of that 12, it's probably going to look a little bit more. Sorry, I need to clear that. All right. And there it's a little bit more symmetrical. So it was a bit skewed because of that 12, which I would have thought was an outlier, but you can see it's a lot higher than the others. So if I put 12 back in, it's going to skew the data a bit more. Ugh. Put it in. Didn't press enter. All right, so there we go. That's why we get that long tail with that 12. So when we do box plots, I'll explain that a little bit more. All right, moving along. Question 15, the amounts in dollars spent by 7 customers at a corner store. So we're going to calculate the mean and median amount spent by the customers. Does the mean or the median give the best indication of the typical amount spent by customers? Explain your answer. Now, if you were doing the mean by a different method, by adding it up and dividing it by how many you've got, it's a long process to do. It's just easier to probably enter your values because you'll get the median at the same time. So even though you've got the formula for the mean, where you add them all up and divide it by how many you have, just putting them into the list is a lot quicker. So, oops, let's go back, edit, clear that away. All right, so just quickly entering those values. Well, that's 16.55. Oh. Must have been hungry that day. I was just wondering what the variable was. Money spent at a corner store. All right, so that 16.55 looks like it would be a, let's have another look. So if I did, not that we need to do box plots, I'm just curious. I think that 16.5 would be an outlier. Oh, look, it's not even, oh, did I? Hold on, let's go back here. Maybe I'm not displaying outliers. Oh, that could be why that 12 didn't come up as an outlier. There we go. Clearly an outlier up here. Yeah, that previous one, I think that 12 would have been an outlier. I just didn't have the outliers ticked. Anyway, we're not doing box plots. I'm getting distracted. So calculate the mean and median amount. So let's just go back up here. And if you ever need to get rid of the split screen, just go to resize. All right, so we're going to calc one variable and put it into list one. And your mean is there, which is 3.65. So we'll write that down. And then your median, we'll just scroll down to find that, 1.7. All right, does the mean or the median give the best indication of the typical amount spent by the customers? Give your answer, explain your answer. So we can see that the mean and the median are different. All right, we've got 3.65 and 1.7. And I can also see this is an outlier. I knew it was an outlier before I'd even drawn that box plot, but that box plot also shows me and it's an outlier. So we can say 6, maybe little kids came in, bought some lollies, all right? We're at a corner store. And then maybe, I don't know, grandpa came in with his 10 kids and they just went crazy and he spent $16.55. So obviously he's an outlier, or what he spent is an outlier. So when you have outliers, you use the median. So the median is often used when you've got data that is skewed, as opposed to the mean, which you should only use if it's symmetrical data, which I think is written in your notes. Let's just have a look. Let me just quickly check. All right, here. So mean versus median. So you should be putting all this into your bound reference and annotating it as well. So it's up to you where you put it, but this is important because sometimes people think, oh, the mean and median you can use for any numerical data. The mean you should only use if it's symmetrical. So you can see there, shape of the distribution is approximately symmetric with no outliers. Once it's skewed or you're introducing outliers, then you use the median. It is much better because basically if you think of all these values, so let's say they're all down this end of a number line, and then you've got 16.55 up here, then think of it as kind of like a tug of war, or this value is pulling those other values up to it. So that's what the effect of the outlier does. It changes the mean, it moves the mean. That's why we don't use the mean with outliers or a skewed data set. So just recapping, just make sure that you take note of this. All right, so we only use the mean when the data is symmetrical. So for this one, we would use the median. All right, median is good for anything. All right, so we'd use the median because there is an outlier present. All right, let's see if there's any more questions. All right, so just quickly have a look at this. For which of the following distributions might you question using a mean as a measure of the center of the distribution? All right, so remember what I said before. If it's skewed, we don't use the mean, we would use the median. So we haven't really looked at histograms yet, but it's either skewed or it's symmetrical. So we can see this is clearly not symmetrical. This is clearly not symmetrical either. All right, what I mean by symmetrical, same on both sides, whereas C is. So we would use the mean for C, but we would definitely use the median for these two instead of the mean. All right, and we would use the mean because it's symmetrical. All right, the distribution is symmetrical. All right, oops, let's keep going. All right, and this will be done in the next video. All right, bye guys.